Yeah, so CP consistency and partition tolerance, right? So let me just scroll it down. So, consistency in partition tolerance, waiting for a response from partition node might result in a timeout error. CP is a good choice if your business needs require atomic reads and writes. Atomic reads and writes, right? So you need to learn about atomicity first. What is atomicity? And like what are this topic you need to learn first. Atomic reads and write. If you want, if that is the requirement of your business, then this is a good choice. And now comes EP, which is availability and not consistent partition tolerance. So how this go hand in hand, right? So response return the most readily available version of the data, right? So this returns most why wait a second, guys. For user returns most readily version of data available on any node. On any node. Ignore my handwriting, guys. That's why it's getting this thing. So, which might not be the latest. Writes might take some time to propagate when the partition is resolved. EP is a good choice if the business needs to allow for eventual consistency. Eventual consistency. Now, this is a amazing topic. Eventual consistency. If business allows for that, I think in ATM transactions or transaction update or balance update in this bank accounts, this won't be allowing eventual consistency. Eventual consistency means when there are multiple nodes, let's say there are N1 node, N2 node, and N3 node, the balance got updated in this. So if it got updated in root node, this will make sure that it replicates or pull the data from this root node. And what will happen? This N2 and N3 node will eventually get updated. Not right now, but eventually it will get updated with the data that N1 is updated with. It will check for any changes in N1 node, and if there are, then it will update it. So it's like a master, and these both are slave architectures. So if your business allows for eventual consistency, then it's good. Otherwise, it's not. Okay. So this was a cap theorem, which is CAP. So this makes a cap theorem, right? Cap means consistency, availability, and partition tolerance. CA and AP. These both are there. Okay. Now comes consistency is done, right? Now consistency pattern. See what are consistency patterns? Consistency patterns. Consistency patterns refer to the ways in which data is stored and managed in a distributed system and how that data is made available to users and applications. There are three main types of consistency patterns. First is strong consistency. First is strong. Second is weak. Third is eventual. And these are consistency. Okay, this word is similar. Consistent. So there are total three types of consistency, right? Eventual consistency, I've already explained it, sort of same thing, but I will go more deeper. Each of these patterns has its own advantages and disadvantages, and the choice of which pattern to use will depend on the specific requirement of your application or system. So let's take a look one by one. So first is weak consistency, right? What is weak consistency? So after an update is made to the data, it is not guaranteed that any subsequent read operation will immediately reflect the changes made. The read may or may not see the recent write. So weak consistency means once the data is updated, read operations will take place, right? Read operations will take place. Now, whenever read operations take place, we do not guarantee that the read operations, that the data that we are returning for this read operation is the most recent updated version. That is a weak consistency, right? Now comes a strong consistency. So, what is strong consistency? So, data updated, right? Data updated. This will be the same. Data is updated. After data is updated, it will immediately visible to the subsequent read operations. So whatever read operations we have after data is updated, read operations, it will have updated data. It will always have updated data, right? Now, eventual consistency, right? Eventual consistency is a form of weak consistency, but upper level of weak consistency. So after an update is made to the data, it will be eventually visible to any subsequent read operations. The data is replicated in an asynchronous manner, ensuring that all copies of the data are eventually updated. So, the same example, N1 node, N2 node, and N3. Why I'm taking this node? Because you might know how Docker works, right? So there are nodes, Kubernetes, right? So Kubernetes, so that's why I'm taking this. So node, right? We have N1, N2, and N3. So this is the root node. Let's suppose this is the root node. This is the slave. This is S2. This slave 2. The data got updated here, right? So after this, this will keep on pulling the data from the N1. This will also keep on pulling the data from M1. This both will get updated eventually, not immediately, but eventually it will get updated. So that is what eventually, that's why we say eventual consistency is a sort of weak consistency, right? And now let's learn about availability patterns. These were consistency patterns. Now availability patterns, right? What are availability patterns? Availability, right? The uptime of the website. For how much time your website is available, right? So availability is affected by system errors, infrastructure problems, malicious attack, and system load, right? So there can be any sort of attacks, cyber crimes, or any sort of, what do we say this? There was one DDoS attack. A cloud application typically provide users with a service level agreement (SLA), which means that application must be designed and implemented to maximize availability, right? So availability patterns. The first is, okay, so availability in numbers. Okay. Let's first learn about failover, right? Failover. What is failover? There is failover. Let me just write the topic. Failover. Okay. So failover is an availability pattern that is used to ensure that a system can continue to function in the event of a failure. It involves having a backup component or system that can take over in the event of a failure. So failover pattern is, you have one system, right? You have S1, you have S2. S2, let's say it's in stable, it's in rest position, and this is active. By some reason, by some DDoS attack, or some attack, some sort of attack happens on S1 or service 1 or system 1, then what our system will do, it will make sure that S2 is up, and this will serve all the requests. So in a failover system, there is a primary component that is responsible for handling requests. So this is the primary component, and there is secondary or backup component that is on standby. The primary component is monitored for failures. If it fails, the secondary component is activated to take over its duties. This allows the system to continue functioning with minimal disruption. Failover can be implemented in various ways, such as active, passive, active, and hot standby, right? So this failover pattern, this thing can be implemented in many ways. So first is active, passive. Second is active, active. So this is for S1 and S2, the two systems. Active, active. Third is what? Active. Third is nothing, right? Third is hot standby. I'm not sure. Hot standby. Okay, hot standby. I think. Okay, hot standby. So first is active, passive, and second is this. Third is this. So what is active passive? With active passive failover, heartbeats are sent between the active and passive server on standby. So heartbeats, if you see this beta stack now, let me just try to sign in here, guys. So let me give this sign in using password. Do I have my password? I don't have my password. Let me just have a screenshot for uptime better tech. If you go to this images, so this you can see, right? Let me just so yeah, this is the official website. So if you see, this is up, it checks every 30 seconds, right? So these are the heartbeats. This is sort of an animation that they have created, but this is sort of a heartbeat. They check every 30 seconds. So this is what active passive means. So it checks, it sent between the active and passive server on standby. So it sends heartbeat to, it sent a request to both of the server and check if those are up. If the heartbeat is interrupted, the passive, so it sends all the every 30 seconds, it sends request to the active server, and if by any chance it doesn't respond or fails, or the request is not 200 with 200 status, so what it will do, it will make sure that this gets up. Passive server, passive system gets up. The length of downtime is determined by whether the passive server is already running in hot standby or whether it needs to start up from cold standby. Only the active server handles traffic. So it depends whether it's on hot standby, means it's already running, or it's ready to run. Only one command needs to be executed, or we need to set up whole environment for the passive system. So it depends if it's on hot standby or not. So this is also part of hot standby, right? So it depends on that. If it's active, then it can be up, and also we like we it won't be like if under 30 seconds it doesn't respond, we have some time limit. Let's suppose that for 2 minutes it continuously it doesn't respond. Some bigger companies like Facebook have this time more or less. It would be around 30 second, I guess, because the user base is high, right? So users cannot user have very small span time, small attention span, right? That's because it will be very smaller for bigger companies, but smaller companies can go up to 2 minute, 3 minute, or 5 minute max. Right, 5 minute can be the maximum downtime that they can handle, or they can be down at. Now active. What is active? Both servers are managing traffic, spreading the load between them. So both servers, let's say S1 and S2, are managing. There is a load balancer. So load balancer make sure that the requests are distributed evenly between both the servers. If the servers are public facing, DNS would need to know about the public IPs of both servers. If the servers are internal facing, application logic would need to know about both servers. So of course, a load balancer would need IP addresses of both servers to manage the load between both the servers. And if we have DNS, so you know, right? You might not know, but if you design a system, you will know that DNS in front of DNS, we can also add a load balancer, and DNS is a public facing server, right? And if we have internal service, let's say there is some front facing service and that talks to S1 and S2. So here we need to save the IP address, right? So there is this reverse proxy and those sort of thing. Then which you can learn, which is used to hide the IP address from the user. So I will come on it later. So what are disadvantages of failover? So what are disadvantages? Disadvantages of failover. What are disadvantages? Let me see if it's recording. Was it's recording? Okay, then great. Failover adds more hardware and additional complexities. Failover adds more hardware and additional complexity. Additional complexity is basically because we need to have two servers and load balancer, maybe we need to have the logic and other things, right? There is potential for loss of data if the active system fails before any newly written data can be replicated to the passive server. So if we have active server, we have passive server. Passive server will make one another point that I forgot, that passive server will always have replicated data. It will keep on copying the data. If while doing this process, if by any chance active server gets down and this is trying to copy the data in sync, it's copying data but it gets down, so there might be some loss of data because it went down before it can entirely copy the data. So that is the disadvantage of failover. And now comes failover is done. Now comes replication, right? Availability patterns. This was the first pattern, which is failover pattern. This was the first one. Now comes the second pattern, which is what? Replication, right? Replication is basically that master slave architecture, right? So replication is an availability pattern that involves having multiple copies of the same data stored in a different locations. In the event of a failure, the data can be retrieved from a different location. There are two main types of replication: master replication and master slave replication. So there are two types: master replication and master leave replication. Okay, so first one, so replication means of course copying the data on different servers which are available on different locations. Let's see, this is Mumbai, right? On Mumbai we have one server, this one server. On this we have in Singapore S2, we have in London S3, we have in New York or Japan S5, S4. So these are the servers that we have, and we need to make sure that our data is consistent between them. So it will keep on replicating, right? So what is master replication? Master replication is in this type of replication, multiple servers are configured as masters, and each one can accept read and write operations. So every server is a master. So this all will be master. So this will be master. And this will also be a master. So each one of them can accept the read and write operations because everyone has updated data, right? This allows high availability and allows any server to take over if one of them fails. So this allows there are availability is high, right? Availability is high because everyone is master, so anyone can accept read and write operations. So availability will always be high, right? However, this type of replication can lead to conflicts if multiple servers update the same data at the same time. So some conflict resolution mechanism needed to be handled this. So there can be conflict between the servers because everyone is accepting the read and write operations. So there can be some complications. So we need to have a mechanism to control that. Now, what is master slave replication? Master slave replication, in this type of replication, one server is designated as the master and handles all the write operations while other slave servers handle read operations, right? So only one this server is the king. This is the king. How do we make a crown? Yeah, this is the crown. So this is the king server. This all becomes slave. This is also slave. This is also slave. This is also slave. This is also slave. Only write operations take place here, and all read operations on slave. Right. If the master fails, one of the slave comes and become master. So if it gets failed by some reason, it gets down. This crown goes to this S2. Right. So it goes to S2. This becomes king, right? So that's how it works. Or and if this becomes master, this becomes master. It's not slave anymore. If the master fails, one of the slaves can be promoted to take its place. This type of replication is simpler to set up and maintain compared to master-master replication. This is simpler and easy to maintain. So this is the master slave architecture basically. Okay, so this was about replication. Now comes availability in numbers, right? Availability in numbers. So what is the acceptable acceptance criteria for availability? Let's learn about it. Availability in numbers. Okay, so what is criteria for this? Availability is often quantified by uptime or downtime as a percentage of time the service is available. Availability is generally measured in number of 9S service with 99.99% availability is described as having four nines, right? Four nines. So a service that is available at 99.99% of time, it is described as 9S, which means it has four nines, right? So one, two, three, four, four nines. So it means it's available at 99.99% of time. So downtime per year, acceptable downtime. So what is acceptable downtime? Let me bring it here. Can I bring it? Not sure. Let me paste it. This is the acceptable. Now paste is table. Okay. Hit paste. Okay. So you can see this is the acceptable downtime, right? Duration acceptable downtime. Downtime per year is 8 hour 41 minute. This is acceptable. Per month is 43 minute. Per week is 10 minute. Per day is around 1 minute. So this is acceptable downtime. This means that this is the acceptable downtime, which means this is 99.9. This is counted as this the criteria for the 99.99% of time. This is for three nines, not four. This is for three nines. If four we want, four should be this one. Let me show you this. Okay. If you want for four nines, this is three nines, three nines. If you want four nines, which is 99.99%. So the downtime per day should be 8.6 second, per week should be 1 minute, 0.5 second, or 4 minute per month, and per year should not be more than an hour. That is the best availability that we can have. Now availability that is done, that is all about availability. Now comes the topic which is background jobs. So what are background jobs? Background process you might know, right? What are background process which runs in the background, right? If you open this task manager, let me open this task manager. You can see some of the processes are running in the background, right? Now let me just go to services. Here are some of the services which are running in background. You can see this is the background service. So it serves to the main application, but it's keep on running on background, right? So Java also have its java.exe which keeps on running in the background. So what are background jobs? Let's learn about that. Background jobs. Okay. So background jobs in system design refer to a task that are executed in the background independently of a main execution flow of the system. These tasks are typically initiated by the system itself rather than by user or another external agent. So background jobs can be like a cron job, right? Cron job can be a background job. Cron job means we are scheduling a task, or cron job is like it runs every 2 or 3 seconds or 1 second or 0.5 second, right? So these are background jobs. This keeps on running in the background. It is not depend. It's independent, not dependent on any process that or application that we are interacting with. It is not run by the user. It's or the external agent. It runs on itself, right? So background jobs can be used for a variety of purposes, such as performing maintenance task, right? Performing maintenance task. So first is maintenance task. So it can be used for that, such as cleaning up old data, generating reports, and backing up database. So one of the company that I was working in, I had this task for which we after installation is done, we need to have a cron job, which not cron job actually. We need to have a background process which makes sure that the file from in where we have extracted this our exe file, because that was an update, right? So updating an application also needs to extract then replace all the files, right? So in that process we need to clean up the older files. So that was the background task. So cleaning up old data, maintenance, this can be a cleaning up old data, right? So first is this can be a background task. Second is what? Processing large volumes of data. Processing large volume of data. What I'm writing here, data. So what it means that if you want to import data from an Excel sheet, or let's suppose there is a big data, there are a lot of images that we need to import. So we can put it in background task, right? We can process it in background without stopping the user from interacting with our application, right? Now, third is sending notifications or messages, right? Sending notifications or messages, such as sending email notifications or push notification to user. So this can also be a background task, right? Sending notification, like you have an app on Android, so your user get your user has unlocked some level, right? Or you are playing a game, right? You have unlocked some of the level. So what you can do, you can run a background process of email notification that yes, congrats, you have cleared this level and you got these many points and what all benefits you can have. And now fourth is what? Performing long running computations, right? Computations can also be a background task. Computations, which means calculating some things, right? Calculating the files, calculating bytes, or calculating some user data, like some sort of calculations. We need to pick the data from the DB or something like that, right? So computations, you can say, computation can also be a background process, right? So that's all about background jobs. Now comes event driven background jobs. Just a second. This can go very long actually, guys. So let's stop here for now. We'll continue after some time.